Okay, here we go. Here's the other new piece. This one's a little bit different, but it kind of ties together a lot of stuff we've already learned. So I'm going to share the screen. And here's what we got. We're now going to kind of combine that angle we did on day 1 and 2 with the trig stuff we did on days 3 and now today, day 4. So what I'm going to talk about is how we take this, because if you think about this, this is kind of like our standard form, standard position angle, the thing you took the quiz on last time. And what you want to think about is like, this is our initial side. This is the initial. And this is the terminal side. And what's going to happen is I'm going to give you a point that will be on the terminal side. I'm going to give you a point that will be on the terminal side. It's going to make an angle. So again, if you think about this, this is an angle in quadrant 1. So this would be an angle between 0 and 90 degrees. But here's how it changes. If you think about this, what's going to happen is when we go to look at the locations or trying to figure out what the measures were going to be, because you're not going to get the numbers, you're going to figure out the numbers. What I want you to look at is take a look at this thing right here and just figure out what we can do is if we actually draw a line, a vertical line straight down from here. So again, I'm going to go ahead and draw a vertical line straight down from here, make a 90-degree angle. If you look at that, we got a right triangle. And what we now have is we have some measures. What we're going to find out is this measure, the distance from this piece to this piece, we're going to define with the letter R. The reason we use R is because actually it's the radius. It's the radius of a circle. And that's where we're moving towards. Eventually, we're going to make a big old circle here, and that'll be our radius. And if you think about the lengths here, well, this point is XY. So if you go from here to here, the length from here to here is going to be X. And the length from here to here is going to be Y. Again, because if you were to think about it, if this point was 1, 2, the length of this would be 1 on the X, 2 on the Y. So now what we have is we have something that we can kind of redefine. Notice on this case that Y is now my opposite. Y is now my opposite. So if we kind of tie it back to what we did before, where we had the hypotenuse, the adjacent, and the opposite, well, we pretty much just have the same thing. So in this case, Y is going to be my opposite side. And X is going to be my, if we look here, my adjacent side. And R is going to be my hypotenuse. So now what it allows us to do is it allows us to redefine all of these definitions that we had before, these SOHCAHTOAs and these cosecant and secants. We can actually redefine them. And when we redefine them, we're going to find out that the sine, and back, the sine of theta, remember, is opposite over adjacent. Remember, we did opposite over hypotenuse, opposite over hypotenuse. That was our SO. Sine is equal to opposite over hypotenuse. Well, opposite is Y, hypotenuse is R. So we're going to redefine it as Y over R. Cosine is adjacent over hypotenuse. Well, in this case, adjacent is X, hypotenuse is R. So we're going to do X over R. Tangent is opposite over adjacent. In this case, opposite is Y, adjacent is X. We're going to redefine it as Y over X. And then remember our cosecant from the previous video. This is the inverse of the sine. What I basically mean is we're going to take the fraction and flip it over. So this is going to become R over Y. Flipping this over becomes R over X. And flipping this over becomes X over Y. So these are our new ways of defining it when we're tying it to that quadrant, to that coordinate planes. Because what we're doing is we're kind of taking everything and we're putting it there. And to kind of go back and figure things out, what I can actually do is I can actually use the Pythagorean theorem to define what R is, because R is that hypotenuse. Remember, a squared plus b squared equals c squared. So x squared plus y squared equals r squared. Well, what I'm going to tell you is the way we can figure out what R equals is we take the square root of both sides, take the square root, and we find out that R equals the square root of x squared plus y squared. So that's how we figure that out. So It seems like out there, but it's something you definitely have done before. We did the Pythagorean theorem, we did sine, we did terminal side and initial side and the angles. It's just kind of starting to kind of tie them all together. So let me show you a couple problems on what they would look like. So what's going to happen now is we want to find the values of our trig functions using this. So if you think about it, we got x, we got y. And if you remember, the way we figure out r is we take the square root of x squared, 4 squared, plus -3 squared. And again, parentheses are important. Parentheses are important. Please use the parentheses. When we do that in the calculator, we're going to find out that r is 5. So we know that x is equal to 4, y is equal to -3, and using our calculator, we find out that r is equal to 5. So now, if I wanted to go ahead and define the trig ratios, sine of theta from the front side is y over r. So it's going to be -3 over 5. Cosine is going to be x over r, 4 over 5. Tangent is going to be opposite over adjacent. In this case, it's going to be y over x. So opposite over adjacent. So it's going to be -3 over 4. And then if we wanted to look at those, cosecant, remember, it's just the inverse. So this is going to be 5 over -3. This is going to be 5 over 4. This is going to be 4 over -3. So that's how we do that with that one. So again, what you're doing is you're defining your x, you're defining your y. So in this case, x is -12. Y is going to be equal to 5. We're going to use that little formula to figure out our r. So again, it's going to be x squared using parentheses, -12 squared plus 5 squared. And you're going to find out that r equals 13. And then what you're going to do is honestly just use these notations, which should be on your index card, to figure out how to write those trigonometric functions. So sine of theta is going to be y over r, so 5 over 13. Cosine of theta is going to be x over r, so -12 over 13. And tangent of theta is going to be y over x, 5 over -12. And then to go the opposite direction, what we do is just take the reciprocal of the fraction. So 13, -12, and -12 over 5. So that's how we do those. Now, what we can do down here is, actually, let me just pause right there. I'm going to go ahead and stop this right now. We're going to kind of stop there. I think what will happen is when I come and see you again on Tuesday, we're going to dive into this. Let's try and get a handle on this piece right here with a little bit of practice, and then we'll kind of build off of it. Please use a reflection. Ask me any questions if you have them. Thanks.